Hello, welcome to section 7.6 everybody, solving radical equations. So this is the last section of chapter 7, and in all of chapter 7 we've been working on radicals and exponents. So we simplified, we graphed, we found inverses, and now in this last section we're going to be given radical equations and equations with rational or fractional exponents, and we're going to solve them. So just a quick review from GO2 before we start. Let's say I had something like the cubed root of x subtract 4 equals to 0. So you may or may not remember from GO2, but to solve this problem, I would add 4 to both sides. So I'd have the cubed root of x equals 4. And then to get rid of a cube root, what you would do is you would cube both sides, because the cube root and the cube cancel each other. So now I have x equals, and 4 cubed is 64. And if I really quickly was not sure of myself, I could check, and if I plugged that into my calculator, I would get 0. And we can also go the other way. So let's say another quick review that I had now x to the 4th equals 16. In order to solve for x, to get rid of a 4th power, I can do the 4th root. And the 4th root of 16 is 2, but because it is an even power right here, because it's an even power right there, I actually could put 2 in there and get 16, or I could put negative 2 in there and get 16. So if I have that even power, there's actually 2 answers. Let me give you another example. Most people are really familiar with this one. X squared equals 9, square root. It could be positive or negative 3. Because a positive 3 squared equals 9, a negative 3 squared also equals 9. So here's what you need to know. If the exponent is odd, there's only one solution. If the exponent is even, there are 2 solutions. But it's going to be complicated here, because if you look at our first example, there's not just a single number, all of them are fractions. So here's what I want to tell you. If the top number is odd, so if the top number is odd, there is one solution. If the top number is even, that's when there's 2 solutions. And I'll help you with that as we go through these examples. So now the way this is different than what you did in GO2 is now we're solving the same type of problems, only with fractional exponents. Now, quick side note, when I had something like x squared, the whole reason you wanted to square root it is really a square root is the same thing as a 1/2 exponent, right? And 2 times a half is 1. So essentially you've turned it just to x because you've been able to cancel out the exponent by making it into a 1. So here's what our strategy is here. With these fraction exponents, our strategy is I'm going to raise this to a power so that when I multiply that power by 3/2, it's going to be equal to 1 for the exponent. And the thing I can multiply by 3/2 to make it a 1 is the reciprocal. So we are going to take both sides to the reciprocal exponent. And here's what I mean. Watch this really quick. 3 times 2 is 6. 2 times 3 is 6. 6 over 6 is now 1 for my new power. And I don't have to write a 1, so now it's just x. I need to figure out what 8 to the 2/3 power is, and if you had forgotten, if I'm doing that exponent, make sure you put that in parentheses in your calculator. You end up with 4. And there's only one answer, because the top number was odd. And if I check this really quick, let's just see if it works. Type that into your calculator. Yes, it does. Alright, part B. So again, if you have a fractional exponent, we're going to take the reciprocal of that exponent. So here I have a 4/5 exponent, so I'm going to raise both sides to the 5/4 power. The 5/4 power. So on this side, 4/5 to the 5/4 power ends up being just 1, and here I got to figure out what 16 to the 5/4 power is, and again you can use your calculator. So I end up with 32, and here's what you need to know. Because it's an even number on top of that fraction, I have to put that plus or minus in for my answer. And see, the thing is, if I did 32 to the 4/5 power, it should equal 16. You can try it in your calculator if you want to quick. hit pause. And then if I tried in my calculator negative 32 to the 4/5 power, I also end up getting 16. So that's why I know that it works. Once you get to more complicated problems, they're not just going to have the fraction, but they'll have other stuff with your variable. So it's kind of like other math where, or like what we did with our first review example, you want to try to get this thing that has the exponent by itself first, then use the power. So I always want to try to get this thing by itself and then do the reciprocal. So in this situation, I can get rid of the 5 because the 5's not with the exponent. 13 minus 5 is 8. And then I am ready, because now my variable is by itself, I am ready to take everything to the reciprocal exponent, and 8 to the 2/3 power ends up being 4. All right, now look at the difference between C and D. Do you see how for C, this 5 right here was outside the exponent? That's why I was able to subtract it off. If we get a situation like D, I actually can't get rid of that 3 yet because it's trapped inside because of that parentheses. So actually this one, this entire thing would be considered the quote variable. So I'm actually ready right away for D to take the reciprocal. So the reciprocal of 5/2 is a 2/5 exponent. A 2/5 exponent. So now I've got x minus 3 equals 32 to the 2/5 power in my calculator is 4. And then I got to pause. I ask myself, do I need to put the plus or minus in front there? Okay, so let me go back to my original problem. Is it even or odd on top? Oh, it's odd. Nice. So I don't have to put the plus or minus in front. Then I'm going to go back and continue solving, and I end up with 7. And remember, every single time you are allowed to go through and check it quick just to make sure in your calculator, does it work? Let's go to part E now. So this one I actually do have a number here that I can get rid of. So I can divide both sides by -2 because it's outside the parentheses, so it's not locked inside there. And I end up with -162 divided by -2 is 81. All right, so I am ready right now to do my reciprocal exponent. And I end up with x minus 3 equals 81 to the 3/4 power is 27. And then I got to pause. Is my top exponent positive or even or odd is my question. And it is even right now. So because it's even, I put the plus or minus here. And here's what that means for my solution. So I'm actually going to split this up then. So I have x minus 3 equals positive 27, and I have x minus 3 equals negative 27. I actually have created 2 different equations that I just need to solve then. So I'm going to add 3 to both sides here. So I got x equals 30, and I'm going to add 3 to both sides here. So I end up with x equals negative 24. And again, you are welcome to go through and check both your answers if you want to. For this type of problem, we are not going to get any extraneous solutions. We will later on in this notes sheet though, so I'll say more in a little bit. All right, one more problem, F. Why don't you pause the video and try it on your own? You are listening again, so I'm assuming you have unpaused. So I am going to go through here and solve this step by step. I got rid of my 6. I'm going to get rid of that number in front, so times by the reciprocal for the number. 8 times 4 is 32, and now I get to get rid of my exponent because now everything else is locked inside. So I'm going to take the 3/5 exponent of both sides, and yay, my original problem was odd, so I don't have to worry about the plus or minus thing. So I just have x plus 4 equals 8, and then I can subtract 4 from both sides, so x equals 4. Again, pause and write that all down if you need to. Alright, so what we just did was when I'm given a variable with a fractional exponent, the rest of the lesson today is all about what to do when I actually have a radical equation that I am trying to solve. So if you're someone who really likes a step-by-step, kind of like our general step-by-step of what we're going to do is we're going to get the radical by itself. So I'm going to say isolate the radical. And then step 2, I'm going to use an exponent. And usually there's only one solution, but not always. Alright, so here's what you got to keep in mind this time. Let's say I had the square root of x equals 4. To cancel out a square root, you square it, because a square root and a square are reciprocals of each other. Alright, so I've got the square root of x being canceled out by the square, so 4 squared is 16. So it's basically what my general scheme of what I'm trying to do when I'm solving radicals. And just like a quick comment, if I've got the cubed root of x equals to something, to get rid of the cubed root I would cube both sides. If I got the fourth root of x equals to something, I would take both sides to the fourth exponent. So do whatever is needed to get rid of that root. Alright, let's look at part A. So this is one where the root is already by itself, so I don't have to add or subtract anything. I'm just going to right away go ahead and square both sides to cancel out that square root. So then I'm left with x plus 1 equals 4 squared, which is 16. I'm going to subtract 1 from both sides, and my final answer is 15. So I'm going to go ahead and check that and just see if it works really quick. So I got 15 plus 1 equals 4, and yep. One thing that I want to point out to you really quick is that when I'm going this way, where the x is underneath the radical, there's not going to be two answers, because there's no way, like if I tried negative 15 for example, it just doesn't work, because when I'm going this way, I can't have a negative under a square root, and this situation would make me have negative 15 plus 1, which would be negative 14. So there's only one answer for a problem like this. Alright, for part B, notice that now my radical part has something in front of it and something outside of it. So just like we did for example A, we have to get this variable part by itself, and anything that's not under the cube root we can get rid of. So I could add 7 to both sides. That's fine. That's not locked away. 3 plus 7 is 10, and I can divide off the 2 because again it's not locked underneath. So I get the cubed root of x plus 1 equals 5. But at this stage, I can't subtract 1, because when you got it under the cube root, it's locked away inside there. So the only way to make that move outside of the root is by taking both sides to the third power. And I want to point out again, this is what I mean by we have to get this variable part by itself. And once that whole thing is by itself, that's when you can use your exponent. Alright, so and when I cancel this, it cancels the entire root, so just x plus 1 is left, and on this side 5 cubed is 125. At this stage I just continue solving, so I actually end up with x equals 124 for my final answer. And again, feel free to check it if you want to. I will require you to check some of them but not all of them, so make sure you listen closely when I give your homework assignment tomorrow so you know what you're doing. And anyways, let's just go through this really quick. Cubed root of 125 is 5. Alright, it works. Thanks for listening, and tune in to part 2 to get the back side of the worksheet.